Hello everyone, welcome back to Logic Unlocked. What's the first missing positive number in an unsorted array? Today's question is that 41 question. Sounds very easy, right? But here's the twist. You must solve it in big of n time and constant space. This is Leetcode 41, one of the most elegant brain twisting DSA problems. In this today's video, we'll go through the induction, dry run, and an optimal C++ code step by step. Let's solve together. Given an unsorted integer array, return the smallest missing positive integer. Ignore negatives and zeros. You must solve this in big of n time and big of 1 space. So, this is the question. The key is we don't care about negatives or duplicates. Here, for this example, we'll be having some negatives also, right? So, we don't care about negatives or duplicates. We want to find the smallest positive number missing. And if we see the intuition, we'll use the index as hash idea. Since we want to find the missing numbers from 1 to n and array size is n, we can try to place each number at its correct index. Put 1 at index 0, comma 2, at index 1, 2 till n, at index n minus 1, like that. We'll swap numbers to their correct positions. We'll be like swapping to sort the array. Okay, we'll be swapping. Then after placing correctly, the first index where array of I not equal to I plus 1. Here is the logic. Like if it is not equal to I plus 1, then that is the answer. That's how we do. For example, if we consider this thing, this carefully look at here, 3 comma 4 comma minus 1 comma 1. Now if we take this, swap 3 with index 2. This is 0 1 2. So swap this 3 with minus 1. Then we'll be getting minus 1 4 3 comma 1. Then ignore minus 1. I said to ignore minus and 0 values. Okay, then swap 4 with index 3, that is 1. So we'll be getting minus 1 1 3 4. Okay, then swap 1 with index 0. Then again if we swap 1 with index 0, we'll be getting 1 minus 1 3 comma 4. Now we can scan. Index 0 is 1, index 1 is minus 1, so we'll be returning 2. So like that it will be happening. So 1 is in the array but 2 is missing. Okay, here 1 minus 1 3 4. What is missing? 2, right? So in place of 1th index, 2 is missing. So we can know that. That's the thing. That's about this code is all. We'll go through this code, and if you can see here, these are the edge cases that here we have mentioned. Like replace all the like if it is replace all the non-positive and out of range values with n plus 1. If it is like out of range, whether it is less than 0 or greater than n, just replace it with n plus 1 value. Because for suppose if we take this as an example, यहाँ पे तो minus 1 is there. So we'll be replacing minus 1 with n plus 1. Here what can be the n plus 1? What is n actually? 0, 1, 2, 3. So 4 is our n. So we'll be taking n plus 1. That is 5. We'll be replacing this minus 1 with 5. So we'll be doing this thing. So this is for that thing. Another loop is for mark present numbers, that is from 1 to n, as negative as the indexes. Why we'll be doing it? Because if value of 3, mark it to be its index is 2 as negative, put the current values as to be negative, because we may already have marked it before. Avoid double negotiation or backflipping. For that sake we'll be doing that. And step 3 will be find first positive index, that is this. For finding the first positive index, the first index I with positive value means number I plus 1 is missing. That's the reason. We'll be assigning remaining all numbers to be minus minus, right? Minus 3 comma minus 4 comma. Here minus 1 is replaced as 5. So minus 3 comma minus 4 comma 5 comma minus 1. Remaining elements we put minus in the second step. In the third step, it is very easy to know which is the lowest like positive value left over, that is this. And we can say it as 2 because 2 is the missing one, as we can see. And index 2 is still positive, so 3 is a missing. That's the thing. No missing found means we can return n plus 1, as you can see here. And that's it, guys. This is the explanation of this code. Hope you have understood. Why is this optimal? Because time complexity is big of n. Each number is swapped maximum once. Okay, next space complexity will be big of 1. Swapping is in place. Elegant logic using index based hashing. No extra space is used for, or hash map is used. This is the first missing positive, a favorite DSA question in top interviews. If you understood the index hashing trick, you have taken one step deeper into mastering DSA. Don't forget to like, share, and subscribe for more DSA hard problems explained cleanly. Next up, we'll be going with another hard question from DSA.